Yo, what's up? Couldn't do it at home. Last night, I was too tired. It was a long day. So, at least we're giving you an updated video. This might be like sporadically put together between now and the end of the day today, where we're finding horizontal, vertical locations, tangent locations to these curves. Remember what we're doing? Yes, we're taking derivatives of y's. It's like, no, it's like we're finding slopes, equations of cool graphs. That's what we're doing. And then we're looking at second derivatives of cool graphs, which could help us determine if we have maxes or mins, if we talked about in class. And then we're introducing finding change formulas at specific times, related rates, derivatives with respect to t. Okay? So get into it. We're starting by taking derivatives with respect to x. Let me increase the font size here. And some things to remember. Taking derivatives of y's include dy dx's. Don't forget the equal sign. Don't forget the derivative of the number. I'm going to solve quickly, subtract, add, factor, divide. You should be able to do this after you've done it enough times, though. If you don't know, haven't seen, do it. Okay? Talk about horizontal tangents, or when your derivative equals 0. If you have a fraction, it's equal to 0 when the top of your fraction equals 0. So you take negative 2x plus 6, you set it equal to 0, you find your answer x equals 3. We could plug that back into the original equation to find the y coordinates that go with that. 9 minus 18 plus y squared minus 4y equals negative 9. I got y squareds and y's. I need to put everything onto one side. 9 minus 18 is negative 9. Add 9, I get 0. So this works out nicely where it's y squared minus 4y equals 0. Factor out a y minus 4 equals 0. Y equals 0 and 4. So we have the points 3, 0 and 3, 4. Vertical tangents are when your derivative is undefined. When you have a fraction. When will we say our fraction is undefined? It's when your denominator equals 0. So you got 2y minus 4 equals 0. You get y equals 2. Key to really this lesson and in math in general is don't forget you have your overall equation, your uniting equation. When in doubt, go back into the original equation. I get x squared minus 6x plus 4 minus 8 equals negative 9. Ooh, I got x squared minus 6x. I get negative 4 plus 9. Negative 4 plus 9, 9, 8, 7, 6, 5. Okay. I get x minus 5, x minus 1. I get x equals 1 and 5. So that means I have the 2 points 1, 2. Make sure you list these off in correct order. X's and Y's. 5, 2. And for fun, let's look at our handiwork. We have x squared minus 6x plus y squared minus 4y equals negative 9. It's this nice tiny circle. We have 3, 0, 3, 4. Boom. We have 1, 2, and 5, 2. All right. Let's look at the next one. Y squared minus 2y minus x to the 4th. Yo, I'm immediately thinking this is going to be tough to find. Plus 32x equals 96. Can't even see it. Whoa. I don't even know if there's vertical tangent locations. I mean, maybe? Looks like there's just horizontal. Right there, right there. 2, 8, 2, negative 6. Let's see. Listen. If you're good with this one, I'm okay if you just find the x's or the y's and not like waste your time doing the extra work. Let's find the derivative, set the equations. Let's find the x, y's for this one. Let's be ready to plug back into the original equation, but sometimes we can't. The ones that I'll give you on your on your quizzes and on your tests, you can. Let's make sure we find the derivative. If you're going to spend any time doing stuff, I'm not going to like say, "Oh, you didn't do this." You're taking the derivatives. You're setting equals. I mean, it seems like it's possible. Might not be possible. Anyways, add 4x cubed, subtract 32, factor out the dy dx, divide to solve. If you need to show each step to get this answer, show it. Okay? Horizontal tangents. 4x cubed minus 32 equals 0. 4x cubed equals 8. Add 32 divided by, x cubed equals 8. X equals 2. Is that what we saw? X equals 2. Yep. Cool. 2, 4, 8, 16. We get y squared minus 2y minus 16 plus 64 equals 96. Y squared minus 2y. 64 minus 32. That's negative 32. Negative 32 minus 16. Negative 48. All right. So do the math. Y minus 8y plus 6. I get y's of negative 6 and 8. So 2, negative 6, and 2, 8. 2, negative 6, 2, 8. Great. What is this vertical tangent situation? I think it's going to be easy, but apparently it's not. Y equals 1. Y equals 1. I don't see any graph when y equals 1, so I'm going to go ahead and say, like, this is one of those situations. And we did this example in class where it's like you think there's a vertical tangent, but if you plug it in, it's like, yeah, that doesn't work. You'd have to somehow solve x to the fourth plus 32x equals, okay, I mean, we'll do it really quick. Y minus 2 minus x to the fourth plus 32x equals 96. Y negative x to the fourth plus 32x, that's a minus 1. So minus 96 minus 97. It's like, yeah, I'm not solving that. Apparently it can't be solved. Don't stress. Just so you got this, but like it doesn't work out. I'm not expecting you to figure that out. Probably on your quiz or on your test, you'd just be asked the horizontal tangents and you just find that. Okay? All right, let's look at this one. X squared 2x negative y squared. Yeah, like I see vertical tangents. I don't see horizontal tangents. Let's find out. Derivative 2x plus 2 minus 2y dy dx equals 0. Dy dx equals minus 2x minus 2 over negative 2y. Subtract 2x, subtract 2. You got to put in the time. If you guys didn't put in the time to find your derivatives correctly, put in the time now. All right. Yep. Look at that. Y squared equals negative 4. I don't have any horizontal tangents. It's very similar to that problem we did in class where it's like we had what we thought was the answer, but when we did the work, we could not find a point. So we'd say there's no horizontal tangents, which we can visually see. Here, if y equals 0, you get x squared plus 2x equals 3. We get x squared plus 2x minus 3 equals 0. We get x plus 3x minus 1. X equals negative 3 comma 1. Okay, this is something I would be expecting you to do, where it's easy enough to see, oh yeah, actually I don't have any points there. It doesn't work out. They're imaginary, but I do have the points negative 3, 0, and 1, 0 for my vertical tangents. Perfect. All right, one more, and then we'll do the harder ones. I'm sorry for being so messy, but I'm kind of rushing here. But I tell you to be neat, because if you're not neat, you're going to make mistakes, and I'm going to make mistakes if I'm not neat. Like, why does that happen? I'm trying not to do that. Don't forget the equals. Don't forget the 0. Subtract 2x, divide out the dy dx, divide to solve. Horizontal tangents, x equals 0. If x equals 0, I got y cubed minus 3y minus 4 equals 0. Like, question mark, question mark. I don't know. Probably none. Wouldn't expect you to figure that out. Vertical tangents, though. When 3y squared minus 3 equals 0, that's when y squared equals 1. Be careful. That's when y equals plus or minus 1. That means there's two locations when y is positive and negative 1. Which means there's going to be like 4 locations of our horizontal tangents. Is that right? So if y is positive 1, let's talk about y being positive 1. This is just like heads up. Like, stuff can happen. Deal with it. You get x squared minus 2 equals 4. You get x squared equals 6. We get x equals plus or minus root 6. So I got root 6, 1, negative root 6, 1. Okay. What if y is negative 1? I get negative 1 plus 3. That's a plus 2 equals 4. So here I'm getting root 2, 1, root 2, negative 1, and negative root 2, negative 1. Let's find out. I don't think there's any horizontal tangents. I think there are 4 vertical tangents. X squared plus y cubed minus 3y equals 4. Oh, yo. Turns out there is. I'm just not going to ask you to find it. This is an upside down uvula. Look at that. Bam. But bam. We found all 4. That's really cool. And we found there was a horizontal tangent. We just didn't know the y coordinate for it. All right. Now, these are the ones we need to spend extra attention for, because like this is what shows up on free response. I'm seeing how much time we got. I'm going to pause and we'll finish this a little bit during lunch, and then post-lunch, post-school, I might have to finish the video. All right, see you in a little bit. All right. It's a lot later than I thought it would be. Didn't get a chance to finish this during lunch, so moving on. These are the more important ones. These are the ones that we see on the free response section of the AP exam, where you got a little bit more going on. It's not as easy to find the horizontal and vertical tangents. Let me see why. Now, first things first, you got to be able to take this derivative correctly. And a lot of you aren't because you're going to forget, because it's been Thanksgiving break, about a product rule. I like to bake in the -3. Get the derivative of -3x times y plus the derivative of y times -3x. Make sure that's in parentheses. You're not subtracting, you're multiplying. And again, I'm going to solve for dy dx quickly. And let's just pick one. Let's just stick with like vertical tangents. Okay, it'd be too much if we did both. I don't have that kind of time. Neither do you. Vertical tangents, but bottom equals 0. Not an easy thing to find. Okay, you don't have an x equals or a y equals number, but you do have x equals y or y equals x. You could solve this equation for either x or y. And then what we talked about in class is how you will still be using the original equation as a system. What we recommend is solving for the easier one and substituting it back in. And you can either pay attention to what's going to be easier to plug back in. Here, it doesn't really matter. I have multiple x's, multiple y's. So I'm just going to pick whatever I want to work with. I like dealing with positives when possible. I will solve for y because it'll give me positive 3/2 x. Easier to work with, so I'm going to do that. Wherever I see y in my original equation, and this is the key, you use your original equation, you're going to replace it with positive 3/2 x. If I solve for x, I'd have, I'd also have positive 2/3. So that's fine. So I got x squared minus 3 times x times 3/2 x plus, be careful, use parentheses, 3/2 x squared. That equals -5. That's x squared minus 9/2 x squared plus 9/4 x squared equals -5. Well, that's fun, Mr. Mester. This is 4/4, 18/4, 9/4. So -9, -5. Multiplied by 4 divided by -5, I get x squared equals 2. 4. I get x equals plus or minus 2. Now, once we have these x equals, we can go back into either equation. The original equation, be a lot of work to do. I don't want to do it. Or the secondary equation. The secondary equation, a lot easier to work with. And when I plug it into my secondary equation, I get 2, 3, or -2, -3. Let's see our work here. This is going to be some sort of ellipse. Or it's, okay, there you go. Something weird. There's the horizontal tangents, which we could have found. Here we found the vertical tangents, 2, 3, and -2, -3. Okay, so pretty cool. You got this kind of parabola-looking thingy, hyperbola-looking thingy. Let's do this one. Okay. Maybe we'll do horizontal here. I'll do whatever's the easier one. Here I got 3. I mean, whichever one is the one we need to do. You know what I mean? Either bake in, leave out. It's up to you. Just make sure you distribute it. Derivative of -x times y plus the derivative of y times -x equals 0. Yeah, I'm going to do the vertical tangents again, not the horizontal. I can do both. Let's do both. I get positive y over 3y squared minus x. This is actually the exact same thing we did in class. This is like the 2021 free response question. Take the numerator, set it equal to 0. Cool. You're trying to find your horizontal tangent. You plug in 0 for y. You get 0 equals 2. Can't be done, which means there's no horizontal tangents. Great. Find your vertical tangents, and here is, the key. Which one do you want to solve for? You want to solve for y and have a square root? I don't want to do that. That's going to make things a lot more complicated than just solving for x. So I get x equals 3y squared. Okay, now these are the important ones. If you're like focusing all your attention on the first page, you're missing out. These are the good ones that have showed up like 2 out of the last 3 years, these implicit derivative questions. Wherever you see x, replace it with 3y squared. You get y cubed minus 3y cubed equals 2. Negative 2y cubed equals 2. Y cubed equals negative 1. The cubed root of negative 1 is negative 1. Negative 1 times negative 1 times negative 1. Negative 1. If y is negative 1, what is x? I got negative 1 minus, it'd be plus x equals 2. X is 3. So 3, negative 1. Let's see. Oh. 3, negative 1. No, y equals value. Perfect. All right. Now, second derivatives. We know second derivatives tell us about concavity. We also know concavity can help us figure out if we have maxes or mins. Keep that in mind. We don't have that situation here, but we do have the need to find a second derivative, and we'll talk about if this were the case. Okay? So what's the key to second derivatives? Find your first derivative, solved for, and then take the derivative of the derivative. I have tried many different ways, and I'm going to do it in a second because I have to try it again, to take the derivative of this and see what happens there. I'm going to do it over here in a second. But instead, the key that I think, the easier way to do this, the way that I think works, is to take the derivative of your dy dx and what it's solved for. And you got to use the quotient rule. And you have to understand that we want a numerical value. So like if you plug in 3, 1, you're like, what the heck is dy dx? Guys, you know what dy dx is equal to. We talked about this in class. It's like right there. So you can replace it with either negative x over y, or you can replace it with 3, 1. So I get negative 1 minus negative 3 times another negative 3 over 1. So it's negative 1 minus 9, which is negative 10. Okay. Concave down. This is a circle. This will be the top half of my circle. We are definitely going to be concave down. Okay. 3, 1. Concave down at this point, 3, 1. Okay. Now, let's imagine this was a horizontal tangent. It's not, but if it were, if you had a horizontal tangent and your graph was concave down, you know that that's a max. This is the second derivative rule, okay? Using a second derivative to help you. It usually shows up on the AP exam, and it's like you are, in the AB exam, you are told, hey, find the second derivative and tell me if it's a max or a min. Now, let me see. Let's take the derivative of this and see if we can get the same answer, negative 10. The derivative of x is 1. Now, the derivative of y dy dx, I'm going to use the product rule. So I got the derivative of y times dy dx plus the derivative of dy dx is that d squared y over dx squared times y. And that still equals 0. I don't know if this is going to work. Let's see. 1 plus -3 times -3 plus. Yeah, I get -10. I mean, it works. So, like, you could take the derivative of your derivative. Just you have to use the product rule. I think it's preferred to solve for dy dx. All right, same deal here. We already found dy dx earlier, so let's just go back. Y over 3y squared minus x. That's gross. The other one's gross too. I'm going to go ahead and plug in -1, 1. I get a fourth. Okay, so remembering that. My second derivative is going to be the derivative of the top. I mean, I'm just like skipping, but I shouldn't. The derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Oh, that's great. Y is +1, x is -1. Okay, so 3 minus -1, 6 times 1 times a fourth times 1 over 4 squared. I mean, it's like, yeah, sometimes arithmetic shows up. 6/4 is 3/2 minus 1 is 1/2. It's 1 and it's a half over 16. It's a half over 16. It's 1/32. Concave up. If this were a horizontal tangent, it'd be a min. We had that one earlier. At -1, 1, our graph is barely concave up. If we look to the right at like 3, 2, we'd see our graph is probably barely concave down. The rate of change is barely positive. So that means we're very close to not having any concavity. It's interesting. Sometimes you'll be given the derivative and asked for the second derivative. Well, that's nice because they already did half of the work for you. You just have to use your rules and make sure you apply what you know. I know what dy dx is. Okay, that means that goes there, or its numerical value goes there. If I plug in 1, 2 into dy dx, that's 4 times 3, which is 12. So it's like 4 times 3 is 12. That goes here. 2 times 2 times 12 times, why am I doing this to myself? 3. That's great. -2 times 4. That's not bad. 12 times 12. That's one of those things that I remembered from a very young age. 144. 132. Yo, this sucker is super concave up. Whatever the original equation is. Oh, here's a good question. What is the concavity of all points in the quadrant 2? All right. Now, I'm not given a specific point, so I can't plug in a specific point. So what I'm going to do is plug in what it's equal to. All right, now let's think about it. Quadrant 2. In quadrant 2, I have negative x's and positive y's. If I plug in a negative x, this will be a negative number. Positive y's, I'll be subtracting a positive number. That means I'll have 2 minus what ends up being a negative number. Subtracting a negative number means that my second derivative is positive, which means my original function is concave up. See how that works? And then we get to the second derivative test, which is kind of what I was leading to in the lesson, is this, because it's very important. It's showing up more and more often on the A/B test. The idea that, okay, -1 is a horizontal tangent. Okay, I can double check, but like it's actually a little bit unnecessary. Yes, if I plugged in -1, I get 0. If I take the derivative, you don't have to use the product rule. I get this. Now, if I plugged in -1, I get -2 plus 0. So this is my second derivative. Now, that second derivative is negative, which means the original function is concave down. Okay. If you have a concave down function and you know you have a horizontal tangent, boom, you know you're going to have a max. This is the second derivative test. This is what we talked about. Okay. Finish thing up with our interlude to the last 2 lessons, which is real world change equations, change functions. What is the constant independent variable in our lives? Time. Time will progress. We will get older. How are things changing at moments in time? Not taking derivatives with respect to x to get dy dx, which is slope, change in y over change in x. Taking derivatives with respect to t to get how x is changing at a moment in time, how y is changing at a moment in time. What's important is that you are used to derivatives of x being 1. Well, that's because you are finding the change in x over the change in x. Well, the change in x over the change in x is like change in x divided by itself. It's 1. We don't have this fancy thing. But if I change what I'm finding the change of, I want to find the change in x at a moment in time. dt stands for like a moment in time, a instantaneous change in t. I get dx dt. That is how quickly x is changing at a moment in time. Okay? That is the idea here. It is only t. How is time changing? Well, time is consistently changing. The derivative of t is 1 now. All that to say, it's like, what's important for you guys? It's still what you're going to do, but it's with a d blank dt after it. Not a dy dx, but a dy dt. You still have the equal sign. You have the derivative of 0. You could divide everything by 2 if you wanted to. Something we'll be doing often. Like the next one. This is the Pythagorean theorem. We'll be using this often in our 4th lesson. It's very similar to what we just did. You got 2x dx dt plus 2y dy dt equals 2 capital D lowercase d dt. And you will be able to cancel all your 2's. Gross, but works. I don't even want to do this one, but it involves a product rule. Whatever, I'll do it. Derivative of 4x times y. Product rule still applies. Derivative of 4x times y plus the derivative of y times 4x. Again, what might help you, what I didn't show, is to take the derivative with respect to t. We're finding how things are changing. We are getting change equations. Like how, if this is the equation of something, and that something is changing on time, like all of a sudden time becomes a factor, this is how it's changing at moments in time. Minus the derivative of r, we're going to say is dr dt. Okay? Now what you're going to see in the final 3 questions are like, hey, You got your change equation. What if I give you some information? Could you find some stuff for me? And the answer should be yes. But what's dx dt if dy dt is -3 when x is 3? Okay, when x is 3, I get 3 times dx dt. This I'm using my change equation because I'm trying to find dx dt. dy dt is -3, and I get equals 0. A lot of you will probably answer the answer is positive 3y over 3, or the answer is y. Not the answer. We are looking for a numerical answer for dx dt. Okay, it might be like a multiple choice question. And you're like, well, I don't want I don't have numerical answers. I want y. So how do we find y? And this is a common theme for this entire lesson. Use your original equation. Your original equation is there to help you find missing values. If x is 3, you get 9 plus y squared equals 10. You get y squared equals 1. You get y equals 1. So y is 1. Dx dt will equal 1. Okay? Same thing goes here. Now, again, let me write this a little bit better. I have x dx dt. Again, I canceled out the 2's because I could, and you will. It's helpful. I get that. Okay? X is 4. Dx dt is 2. I don't know what y is. Dy dt is 3. 5. I'm trying to find d dt. Okay, I have all the information except for y. How do I find y? Use the original equation. The original equation is always there to help you. Don't ever forget about the original equation. It'll always be there. 4 squared plus y squared equals 5 squared. Y squared equals 9. Y equals plus or minus 3. In this remaining part of this unit, we're going to be talking about how distances are always positive. We don't like to call distances negative. We could, but we're going to stick to the positive land. So we're going to say it's not plus or minus 3, or we're going to just say it's the positive 3. So I get 8 plus 9 equals 5d dt. I get 17/5. Okay? Doing this extra step. We did it in class. I think we got to it in class for most of us. X equals y equals r equals 1. Dx dt 2, dy dt 3. 4 times 2 times 1 plus 3 times 4 times 1 minus dr dt. I don't even need r, is 0. 8 plus 12, 20 minus dr dt equals 0. Dr dt is 20. This is like the beginning of the next 2 classes. Next class, next lesson. Formulas, equations. Not just of x's and y's, but v's and r's and c's. Circumference of circles. Circles will be growing. People will be moving. Things will be changing. Talking about how they are changing. Calculus. Calculus and derivatives will give you change equations. We'll get there. Okay? All right, I'm finally out. So let's see how this video records. Peace!